I'm going to use a Fourier approximation method to find the initial basic feasible solution, then go on and use the modified distribution method to find the optimal solution. So for our transportation problem here, we are having three sources, F1, F2, and F3, four destinations, A, B, C, and D. The values in the small squares here are indicating the unit costs. And then when we look at the supply, we are having these values 140 plus 60. When we add them, they give us a 200. And then for the demand, we are having these values here 30, 50, 65, 55. And when we add them, they give us a 200. So we are having the supply and demand are equal. So we are looking at a balanced transportation problem. So we have that problem there. And to use Fourier's approximation method, we start by calculating the penalties. For the penalty is the difference of the smallest and next smallest unit cost. So we have tables for penalties for rows and columns. So I'll start by looking at the row F1 there. The row F1, the smallest unit cost there is the 12. The next smallest is this one here, the 14. The difference is a 2. Then go on to row F2. We have the smallest unit cost there is this 8. Then the next smallest is this 10. And the difference there is a 2. Then go on to row F3. We have the smallest cost there is this 8. The next smallest is this 10. Then the difference there is a 2. Then we now go on to the columns. So start with column A, and the smallest cost is this 10, and the next smallest is this 12. And the difference there is a 2. And then we go on to column B. The smallest there is a 14, and the next smallest is a 16. Then the difference there is a 2. And then column C, the smallest cost is an 8, and the next smallest cost is a 10. And then the difference there is a 2. Then lastly, we look at column D. The smallest cost is an 8, and the next smallest cost is a 15. And the difference there is a 7. So the next step is to look at the row or column with the largest penalty. So the row or column with the largest penalty, we see that column D is the largest penalty there, which is a 7. So what we have to do is we have to allocate as much as possible in column D there, but to see which cell we have to allocate, we allocate in the cell with the least cost in that column D. So that cell is this one there. It is the unit cost of 8. So to see how much you can allocate, we look at the supply, it's a 40, the demand is a 55. So we allocate the minimum of 40 and 55, and that value is a 40. But the moment we allocate 40 here, it means that we can no longer allocate in other cells that are lying in row F2 because we have met this constraint there for the supply, which is 40. So I would cross here to indicate we are no longer allocating. So then cross out again here on the penalties to indicate we are no longer calculating the penalties. Then when we allocated these 40 units, for the demand, we would have to subtract the 40. So we'll be left with 55 minus 40, which gives us a 15. And then we go on to the next step. We now calculate the penalties again for the rows and the columns, but now excluding the ones that have an allocation or the ones that have been crossed out. So we go on to the next step there. For the penalty for row F1 there, we are having the smallest is this one, 12. Then the next smallest, 14. Then the penalty there is a 2. And then for row F2, we are not calculating. Go to row F3. The smallest cost there is an 8. And the next smallest is a 10. The difference is a 2. So we are done with the rows. And then go on to the next column, which is column A. And the smallest cost there is a 10. And the next smallest is a 14. The difference there is a 4. And then we move on to column B there. And the smallest cost is a 16. The next smallest is a 16 as well. So a difference of 16 and 16 gives us a 0. And then we go on to column C. The smallest cost is an 8. And the next smallest cost is a 12. So the difference there is a 4. Lastly, column D, the smallest cost there is a 15. Then the next smallest cost is a 20. The difference is a 5. And then we go on and look at the column with the highest penalty. The highest penalty that we're having there is a 5, which is corresponding to column D. So we look at column D and look at the cell with the smallest unit cost. The smallest unit cost is appearing in this cell here with the 15. And then we go on and allocate as much as possible. To see how much we can allocate, we look at the supply, which is a 60, and the demand, we are now left with 15. So we allocate the minimum of 60 and 15, and we allocate 15 units there. But the moment we allocate the 15 units, we have now reached the demand constraint there for column D. So we can no longer allocate anymore in column D. So I'll cross out here to indicate we can no longer allocate. And I'll also go on and cross out to indicate we will no longer calculate the penalties here. But when you allocated the 15, it will affect the supply here. So we have to subtract that 15 from the 60, and we remain with a 45. So that is what we are having now. And we now move on to the next iteration. We now go on and calculate the penalties again, but leaving out the occupied cells or the cells that have been crossed out. So for row F1, we are having the smallest cost there is this 12, and the next smallest is a 14, and the difference, it gives us a 2. And then for row F3, we are having the smallest cost there is an 8, the next smallest is a 10. Then the difference there is a 2. Go on to the columns. For column A, the smallest cost is a 10, the next smallest is a 14, and the difference there is a 4. And then we go on to column B, and the smallest cost there is a 16, the next smallest is a 16, the difference is a 0. Then we go on to the next one there, column C, the smallest cost is an 8, and the next smallest cost is a 12, and the difference there is a 4. So I'll put a 4 there. So we are done with our penalties. And then we go on and look at the row or column with the largest penalty, of which in this case we are having this one here for 4, 4. When we have a tie, we take the lower numbered row, lower numbered column. So the lower numbered row, lower numbered column, we would have to take this one first here, the 4, which is appearing in the first column. So we go on and look at that column and look at the least cost. We have this cell here, which is as the 10. So we allocate as much as possible in this cell. To see how much we can allocate, we look at the supply. We are now left with 45. The demand, we are left with 30 there. So we take the minimum of the 45 and the 30, and the value that we get is a 30. So we allocate 30 units here. But the moment we allocate the 30 units, we have reached the demand for column A, so we can no longer allocate anymore in A. So I'll cross out on this cell to indicate we can no longer allocate, and then cross out again on the penalties to indicate we are not going to calculate the penalties. And then we go on and adjust our supply. We were left with 45, but we removed the 30, so it will be 45 minus 30, and we are left with 15 units there. And then we go on to the next step, calculating the penalties again for the rows. For row F1, we are having the smallest cost there is a 12, and the next smallest is a 16. And the difference there is a 4. Then we go on to the next row, which is F3. So for F3, the smallest cost there is an 8, and the next smallest is a 16. And the difference there is giving us an 8. We are done with the rows. We go to the columns. So for the columns, we are looking at column B there. And the smallest cost is a 16. The next smallest is a 16 as well. So the difference there is a 0. Then we go on to column C, and the smallest cost is an 8, and the next smallest is a 12, and the difference there is a 4. So we are done with the penalties there. Then we look at the row or column with the largest penalty. The largest penalty that we are seeing there is this 8. So we are looking at row F3. For row F3, the smallest unit cost there is this cell here with an 8. So we have to allocate as much as possible. To see how much we can allocate, we look at our supply. Our supply, we are left with 15 units. And for our demand, we are having 65. So we take the minimum of 15 and 65, and therefore we allocate 15 units in this cell. But when you allocate the 15 units in this cell, we now add up to the 60, which was the supply constraint. So you can no longer allocate anymore. So I'll cross out this cell to indicate we can no longer allocate. Then I'll also cross out on the penalties there to indicate we are no longer calculating penalties for row F3. Then we need to adjust our demand. It was a 65. We removed 15, so we will remain with 50. So that's what we have now. Then we go on to the next iteration again, calculating the penalties. So we start with row F1 there, and the least cost is a 12, and the next least cost is a 16, and the difference there is a 4. Then we are done with the rows. We go on to the columns. So we are now looking at column B, and the least cost there is a 16. So that's the only one that we have there. So we just write the 16 there. Then we go on to column C, and the only cost that we are having is a 12. So we write the penalty there is the 12. And then we go on and look at the row or column with the largest penalty. The largest penalty is this 16 here. So we allocate as much as possible in this column, but we are allocating in this cell here with the 16 unit cost. To see how much you can allocate, we look at our supply, which is 100, our demand, which is 50. So we look at the minimum of the supply and the demand, which is 50. So we allocate 50 units there. But when you allocate the 50 units there, that means we are done with column B. So I'll go on and cross out on this part here to indicate we are no longer allocating penalties. And then we go on and adjust this supply there, the 100, we remove the 50, so we remain with 50. And then we go on to the next step, calculating the penalties there. We are only having a 12 there for F1, so the penalty will be a 12. And then again, for column C there is just a 12. But this is the only cell which is remaining, so we have to allocate just to this cell. So to see how much we can allocate, we look at the supply, it's a 50, and then the demand, we are left with 50 there, so we allocate 50 units in this cell. So what we are having there, the initial basic feasible solution using the Four-Jaws approximation method is giving us these allocations there. So I will now move on to finding the optimal solution using the modified distribution method. So we now apply the modified distribution method to these allocations that we have just obtained. So the first step is to calculate the dual variables ui and vj. We calculate this for each occupied cell. So the occupied cells that we have are these ones here. And the formula that we use there is Cij is equals to ui plus vj, where the Cij will be the unit cost in the occupied cell that we will be looking at. So for each row, we would have a U, and for each column, we would have a V. So we would have a U1, a U2, a U3, V1, a V2, a V3, and a V4. So to begin with, we start by setting one of the UI or Vj to be equals to 0. It is convenient to choose this U that we set to be equals to 0 to be the one with the most occupied cells in its row or column. This will simplify the calculations. So if we look at the row or column with the most occupied cells, we are having this row here, row F3. It has 3 occupied cells. So we set that row there to have our U3 to be equals to 0. So I'll put my U3 there is equals to 0, as it is the row with the most occupied cells. And then we go on and use this formula here to calculate the other dual variables. So we are looking at occupied cells. So for this cell here, we are having a unit cost of 10. So when we add this U, which is 0, and this V, then we get 10. So that will give us V1 there is equals to 10. Then look at this occupied cell here. We will be saying that 8 is equals to the 0 plus V3. So V3 will be equals to 8. Look at this cell here. We'll be saying that the unit cost, the 15, is equals to the 0 plus V4. So the V4 there is equals to 15. And then we go on and look at this occupied cell. we'll be saying the 8 is equals to U2 plus the V4. And that will give us the U2 there being equals to minus 7, because we'll be having 15 minus 7, which will give us the 8. And then we go on and look at this cell here. We are saying that 12 is equals to U1 plus 8. So we would have that our U1 there will be equals to 12 minus 8, which gives us a 4. Then lastly, we look at this cell here. We will be saying 16 is equals to the U1 plus V2. So we would have that our V2 there is equals to 16 minus 4, which gives us a 12. So we now have our dual variables there, U1, U2, U3, V1, V2, V3, V4. And then we go on to the next step, which is to calculate the opportunity cost for unoccupied cells. So the formula for calculating that opportunity cost is given by Dij is equals to Cij minus Ui plus Vj. We are using the Ui and Vi that you have just calculated, and this Ci here is the unit cost for that particular unoccupied cell. So I'll go on and draw a table where we have the cell, then we will write the value of the Dij, the opportunity cost. So we start by looking at this cell here from F1 to A. So from F1 to A, using our formula here for our Dij, it will be the 14, then minus 4 plus 10. So it's 14 minus 4 plus 10, and that value there is a 0. Then we go on to the next cell, this one here, F1 to D. For F1 to D, we are looking at our cost there is a 20, and then minus the sum of these two values here. So we'll be having there 20 minus 4 plus 15, and that will give us a 1. Then we go on to the next cell, this one here. We are having the cost there is at 12, then minus the sum of these two values. So it will be 12 minus 7 plus 10, and that will give us a 9. Then we go on to the next cell, which is this one here. That's F2 to B. So we are looking at a cost of 14 there, and we are subtracting the sum of these two values. So it will be 14 minus 7 plus 12, and that will give us a 9. Then we go on to the next cell, which is this one here. We are looking at cell F2 to C. And the cost there, we are having a 10, and we are subtracting the sum of these two values. So we'll be having 10 minus 7 plus 8, which will give us a 9. Then lastly, we'll look at this unoccupied cell here, which is F3 to B. So for F3 to B, it will be 16 minus the sum of these two costs. So it will be 16 minus 0 plus 12, and that will give us a 4. So what we are seeing there is the opportunity costs for all the unoccupied cells are greater than or equal to 0. So we conclude that the solution there is optimal. So we are having our optimal solution, yes, these allocations. So what we are having there is the allocations that we had for the Vogel's approximation method are turning out to be the optimal solution. Then we just go on and interpret. So I will draw a table where we have the destination, the allocation, and the cost. So for the first one, we are having from F1 to B, we are allocating 50 units. 50 units at a unit cost of 16. So the cost there will be 50 times 16, and that will give us 800. Then we go on to the next one there. We are looking now at F1 to C. We are allocating 50 units. 50 units at a unit cost of 12. So the cost there will be 50 times 12, and that will give us a 600. Then we go on to the next one there. We are looking at F2 to D. F2 to D, we are allocating 40 units. 40 units at a unit cost of 8. So the cost there will be 40 times 8, which gives us a 320. Then we go on to the next one. We are now looking at F3 to A. For F3 to A, we are allocating 30 units. 30 units at a unit cost of 10. So the cost there will be 30 times 10, which gives us a 300. And then we go on to the next one there, which is F3 F3 to C. F3 to C, we are allocating 15 units. 15 units at a unit cost of 8, so the cost will be 15 times 8, which will give us 120. Then lastly, we are looking at F3 to D. F3 to D, we are allocating 15 units. 15 units at a unit cost of 15, so the cost will be 15 times 15, which will give us a cost of 225. Then we go on and add those costs so that we get a total of 2,365. So we are having the optimal solution is these allocations that are appearing on the left, and it is giving a cost of 2,365. So that's our optimal solution there.